Physics, and welcome to your lesson 6.5. We're going to talk about the sampling distribution of a sample. Today, we're going to do all this stuff. It's going to be cool. Or at least we believe it will. All right, so we would need to know the sampling distribution of the sample mean x bar. Right, and it tells us all of the possible means if we're to take samples of the same size from a population. Okay, that is the sampling distribution of our sample mean x bar. We can also calculate the mean and the standard deviation of the sampling distribution of the sample mean. And this is how it's going to look. So we get a population standard population mean that's going to be the same as your sample mean. It's going to be the same as the sampling distribution of your sample mean. And your standard deviation is going to be a little different. You're going to take your population standard deviation and divide it by the square root of your sample size. That's what n is. So sample x bar is known by its estimator. Of course, the standard deviation describes the typical distance or the average distance from the value of a sample mean from the population mean. And facts. So if you want to describe it, there it is. Right? And it's important to say that if you're sampling from a normally distributed population, then the distribution of your sample means is also important. Sometimes I like to just put deodorant on one armpit so that I'm like half smelling good and like half itching. It just confuses the crap out of people. Like, wait, I smell deodorant. Wait, I smell BO. One or the other. Okay. All right, let's go ahead and do an example of a problem of like your assignment. Our color is your color. If so, then I wouldn't be dating color. Right. The heights of young women follow a normal distribution with a mean of 64.5 inches and a standard deviation of 2.5 inches. We're going to calculate the mean and standard deviation of the sampling distribution of x bar for simple random samples of size 15. So for what? Mu sub x bar, the mean of the sampling distribution of my sample mean, is the same as the mean of my population, which in this case is 64.5. The standard deviation of the sampling distribution of my sample mean is going to be equal to the standard deviation of my population divided by the square root of my sample size, which in this case is, I believe, 2.5. Oh. Divided by the square root of 15. Let's go ahead and put that in our handy dandy calculator and get an approximate value. 2.5 divided by the square root of 15. is approximately 26 for number one is done. Hey, let's do number two. No, we're not going to actually do this. We've done this question. Now let's find a probability. Yes, that's it. And I believe your assignment is only two questions. Find the mean, find the standard deviation, and calculate a probability. So now we're going to find the probability that the mean height of a simple random sample of 15 young women exceeds 66.5 inches, which is taller than me by an inch and a half. Are they taller? It says that they're only 64.5 inches. I would say that if you're shorter than me, you're not tall. That's pretty much how that goes. Let's see. So I'm going to choose to do normal CDF to calculate. Right? Remember, this is in the form lower bound, upper bound. And we'll put our mean and our standard deviation. Remember that this standard deviation here is the standard deviation that we just calculated in one, right? We're not looking at the standard deviation of the population, we're looking at the standard deviation of the sampling distribution of the sample mean. So in this case, that's like normal CDF. What are you looking for? We're looking for the probability that it exceeds 66.5 inches, right? So it can't be less than that, right? We're looking for the probability that it's over 66.5. So that's going to be our lower bound. Our upper bound, I'll put as some big old number. You can just put a big number if you want. Do all that. My mean was 64.5, and we calculated the standard deviation of the sampling distribution of the sample mean, which turned out to be 0.645. All right, let's go ahead and put that in our calculator and calculate a probability. We'll get some approximate value for this from our calculator. All right, so let's get that thing out. And I'm going to go to second bars. I'm going to choose normal CDF. My lower bound I said was 64.5. Oh, my bad. That is not true. My lower bound was 66.5. Upper, we'll just put a big old number. Our mean was 64.5 with a standard deviation of 0.0. 0.645. I'll have pasta. All right. And we get a pretty low value, right? This we're going to write this as point. Whoa. Even before? 965. 1, 2, 3, 9, 6, 5, right? And there you go. We found the mean and the standard deviation of the sampling distribution of the sample mean, and then we calculated the probability that a sample has a mean of 66.5. It's pretty low. A sample of 15. All right, so there you go, guys. Your assignment that you'll have to correspond to this is going to be just the same. 2 questions: mean, standard deviation, calculated probability. Call it good. Thanks so much for watching, guys, and I hope you have a fantastic day. And if it's not fantastic, I hope it gets better. Take care of yourselves and each other. Merry Christmas.